Which of the following reactions would occur the fastest? If we look at all of these reactions, we see that they all form the same tertiary alcohol as a product, and they are all using the exact same solvent, which is going to act as a nucleophile in this reaction. And so what's different is the structure of the substrates. So these are all substitutions. This means that they are either going to occur via an SN1 reaction or an SN2 reaction, because those are the two substitution pathways we have seen for alkyl halides. To determine which pathway, we want to look at the structure of the alkyl halides. And what we see is that all of these carbon atoms are equally substituted, and they are all tertiary alkyl halides. And so with tertiary alkyl halides in a substitution reaction, we are looking at the SN1 pathway. And so let's quickly draw the mechanism for this SN1 pathway. I'm just going to use X for my halogen. And so what happens in an SN1 reaction is the first thing that takes place is the leaving group will leave. And this will give us a carbocation. This is the slow step of this mechanism. So the better that leaving group is, and the more stable the carbocation is, the faster it will occur. So all of these will form the same carbocation. That won't distinguish it. What's different is the identity of the leaving group. So the reaction conditions that have the best leaving group will be the fastest. And the best leaving group is the weakest base. So in comparing the halogens, the weakest base is going to be the largest one. So that would be iodine. All right, so we've answered the question, but for additional practice, I'm going to continue and finish this mechanism. So after this dissociates, now you've got a carbocation that's a high energy intermediate, and even a weak nucleophile like water will quickly react with this carbocation. And so we formed a new bond to oxygen, and that oxygen still has bonds to 2 hydrogens. And to get to the neutral alcohol, we need to deprotonate. Water is the solvent in this reaction. This is a solvolysis reaction. And that means that we have plenty of water around, and so we can have another water molecule do the deprotonation step to get to that final alcohol. And so I just need 2 arrows here. I can remove either one of these 2 protons, they are equivalent, and deprotonate to get that alcohol.